In this video, we will try to understand the basic concepts of speed, time and distance. First, we will try to establish relationship between speed, time and distance, and then we will move towards the conversion of units. So let's begin. First of all, my question to you all is, why do we study speed, time and distance in the same chapter? Because when we look towards speed, time and distance from our day-to-day life perspective, we see all of them pretty different from each other. Like if we talk about speed, we can think a, a vehicle is traveling with the speed of x kilometers per hour. If we think of a distance, then we can think of a distance between two places. Distance between two places. And when we think of time, we can think of a time on clock, any time on clock, any time on clock, or to finish a certain task in the given time. To finish certain task in the given time. We can see that all three are pretty much different from each other. Then why do we study all of them in the single chapter? So we'll first try to establish relationship between speed, time and distance. In mathematics, when we talk about distance, let's say this is point A and this is point B. On point A, two friends, Santa and Banta, are standing. Santa and Banta are standing. Let's say Santa have a cycle with gear and Banta have a normal cycle without a gear. And the distance between them is x kilometers. So Santa with his cycle can travel with a speed of, let's say, 4 kilometers per hour. And Banta with his cycle can only travel with the speed of 2 kilometers per hour. Santa takes 15 minutes to cover the distance between A and B, and Banta takes 30 minutes to cover the distance between A and B. What we have saw is that when we have increased the speed, the time to travel the distance got reduced, and when we have reduced the speed, the time taken is automatically got increased. So from here we can conclude that speed and time are inversely proportional to each other when distance is same. Because when we have increased the speed, time got reduced, and when we increase the reduced the speed, time got increased. One more example. Let's say we put time as our constant. Time as our constant. Let's understand with the help of diagram. Again, there's two places, A and B, and again Santa and Banta. Santa is standing. This time Santa is standing on A, and Banta is standing on point C. Here Banta is standing, and both of them take 2 hours to reach point B. Both of them take 2 hours to reach point B. But in this case, Santa is traveling more distance and Banta is traveling less distance. So obviously Santa have to increase his speed, and Banta can go in the normal speed. Let's say Santa take 2 hours at the speed of 50 kilometers per hour, but Banta take 2 hours but Banta take 2 hours only with the speed of 15 kilometers per hour. So we can say that when the distance is increased, the speed also got increased, and when we reduce the distance, the speed also get reduced, because Santa is traveling this distance but Banta is traveling only this distance. That is why Santa needs to increase his speed to 50 kilometers per hour, and Banta, who is closer to point B, can go with the speed of 15 kilometers per hour only. So in this case, we can conclude that distance and time, distance and speed are directly proportional to each other. One more example. First we took distance as constant, then we took time as constant. Now we will take speed. Now we will take speed as our constant. Again, same scenario. Santa is standing at A, Banta is standing at point C, and both are traveling with the speed of, let's say, 60 km per hour. Both are traveling with the speed of 60 km per hour. So time taken by Santa is 4 hours, and at the other hand Banta takes only 2 hours to reach point B. In this case, we have seen that Santa is traveling more distance than Banta, and that is why time taken by Santa is more than Banta, because both of them are traveling with the speed of 60 km per hour. So we can conclude that both distance and time are directly proportional to each other when we take speed as constant. So this was all about the relationship between speed, time and distance. Now we will try to understand how the conversion of unit takes place. First, we will take unit of distance. We will start with unit of distance. Let's say kilometers, hectometer, decameter, meter, decimeter, centimeter, and millimeter. We know that 10 hectometer is equals to 1 kilometer. 10 hectometer is equals to 1 kilometer. 10 decameter is equals to 1 hectometer. Similarly, as we go downwards, we will multiply it with 10. And we can also say that 1 kilometer is equals to 1000 meter, because 10, 10 and 10. And similarly, 1 meter is equals to 100 centimeter, 10 and 10. As we move upward, we will divide it with 10. We will divide it with 10. So this was all about the unit of distance. Now we will look to one second. Now we will see how the unit of time or conversion of unit of time takes place. Unit of time. If I want to change 1 hour into minute, I need to multiply it with 60. Similarly, if I want to change 1 minute into hour, then I have to divide it with 60. If I want to change 1 minute into seconds, then I have to multiply it with 60, and again 1 second into 1 minute, that is 1 by 60. 1 hour into seconds, that is 3600. 60 into 60, first we will convert hour into minute, then minute into seconds, that is 60 into 60. Again 1 second into hour, that is 1 by 3600. So this was all about conversion of unit of time. Now we will see how this unit of speed takes place. We often got confused how to change kilometer per hour into meter per second into meter per second. So what we are doing here is we are changing kilometer per hour into meter per second. And as we have saw that 1 kilometer is equals to 1000 meter. 1 kilometer is equals to 1000 meter. So we will put 1000 in the numerator, and 1 hour is equals to 3600 seconds. After terminating both the terms, we will get 5 by 18 as our result. So if I want to change kilometer per hour into meter per second, then I have to multiply it with 5 by 18. Again, if I want to change meter per second into kilometer per hour, then we will multiply with the reciprocal of the fraction, that is 18 by 5. That is 18 by 5. Now, if I want to change kilometer per hour into meter per minute, then again we have to do the same procedure, that is kilometer per hour and meter per minute. And as we know, 1 kilometer is equals to 1000 meters, and 1 hour is equals to 60 minutes. After terminating both the term, we will get 50 by 3 as our result. So if we want to change kilometer per hour into meter per minute, then we will simply multiply it with 50 by 3, and vice versa, if we want to change meter per minute into kilometer per hour, then we will multiply it with the reciprocal of the fraction, that is 3 by 50. So this was all about the basic concept of speed, time and distance and conversion of unit. In the next video, we will try to solve the questions based on the above topic, above explanation, and try to have a look at the different approaches to tackle them.